This is 10-3 composite figures. Let's start with the warm-up. Hit play when you're ready to see the answers. So the number 1 warm-up problem is 70 centimeters squared. Number 2 is 54 inches squared. And number 3 is 12 feet squared. Okay, in a composite figure, we have a bunch of simple shapes combined into one figure. So you have to find the area of all the simple shapes and add them up. That is called the area addition postulate. So a composite figure is where there's maybe two shapes put together. So for instance, like a house doesn't have to have that line in between, but you could then create a triangle out of it and a rectangle. So when you find the area of each one of those and add them together, that's area addition postulate. We've had addition postulates before, like segment addition postulate. So if segment AB is 5 and segment BC is 4, then the total segment AC would be equal to 9. And we had angle addition postulate, where if we said angle ABC was made up of these two angles, ABD and DBC, and I told you that this angle is 40 and this is 20, and you could tell me that the measure of angle ABC is equal to 60 degrees because of the angle addition postulate. Here's some basic area formulas. All of these will be provided for you on a test because they will also be provided on the SAT. So for parallelogram, we have A equals BH. In a triangle, we have A equals 1/2 BH. And for a trapezoid, we have A equals 1/2 B1 plus B2 times H, or this is just another way to write it. Rhombus and kite should be the only thing that you haven't really seen before, which is A equals 1/2 D1 times D2. And the D's stand for diagonal, so diagonal 1 times diagonal 2, and then half of that. And for circles, we have circumference, which is the distance around, that's pi d or 2 pi r. And we have area, the space inside, which is pi r squared. Now, these are composite figures. Composite figures are made up of 2 or more figures. So the first thing I see is a semicircle. And the second thing I see is a trapezoid, or possibly a rectangle and a triangle. Those aren't drawn the best, but I like to separate these because I know that to find the area of a circle, it's pi r squared. But since I have a semicircle, it's going to be cut in half or divided by 2. So pi r squared divided by 2 for that one, plus this trapezoid. Well, a trapezoid is 1/2 B1 plus B2 times H. Sometimes the H is in the front. I've seen that before too. But then from there, I can just kind of plug in my numbers. So for the pi r squared, pi times, well, that's the total diameter. Diameter goes all the way across, so the radius is 10. So pi times 10 squared divided by 2. 10 squared is 100, divided by 2 is 50 pi. So remember, you can leave your answer in terms of pi. Plus the trapezoid, 1/2 B1 plus B2, that's 20 plus 32, times the height, which is 14. So equal to 364 millimeters squared and millimeters squared. And so since we left our answer in terms of pi, we wouldn't be able to add these. They're unlike terms, basically. So 50 pi plus 364 millimeters squared would be the answer. Or you could actually multiply 50 times pi and then add it to that 364, which would give you approximately 521 millimeters squared. So in this one, the two shapes I see is a parallelogram that has a base of 8 and a height of 5. And a parallelogram is equal to base times height, so I know that area is 5 times 8, or 8 times 5, doesn't matter. And so that's going to be 40 feet squared. And then for the triangle, we have a base of 10 and a height of 5. So the area equals 1/2 BH. That's going to be 1/2 times the base is 10 times 5. And so this area is 25 feet squared. And then we add them together to get the total. So it's going to be 65 feet squared is what the area is equal to of this composite figure. The two shapes I see here, we have a rectangle, which is length times width or base times height. That's going to be 22.5 times 37.5. That's 843.75 meters squared. And we also have a triangle, which is going to be A equals 1/2 BH. And I can figure out the base because we've used 37.5. So it's actually cut in half. These are each 37.5 to add to 75. So basically I subtracted 75 minus 37.5. So I know that the base is 37.5. But the problem is I don't know the height. The good thing is that since I have two sides of the triangle, I can use Pythagorean theorem. So I'm just going to take a minute in order to find height. I'm going to do a squared, we'll call it h since it's height squared, plus b squared, 37.5 squared, is equal to 62.5 squared. And let's solve for h. And when I solved with Pythagorean theorem, I got that h equals 50. So now I can replace that h that I had with 50, and I can go ahead and calculate. So 1/2 times 37.5 times 50, which is 937.5, and I can add these two together, meters squared. (1,781.25 meters squared). These are a little bit different because something's been subtracted here. So in this case, we have a triangle minus a semicircle. Remember, a semicircle is 1/2 pi r squared, and a triangle is 1/2 base times height. So I plug that in. 1/2 times the base, which is 18, times the height is 26. And then for the other one, it's going to be 1/2 times pi times radius, which is going to be 4.5, since the diameter was 9, squared. And we're going to subtract these numbers. So once I calculated my answers and subtracted, I ended up with 202.2 rounded to the 10th feet squared. So in this one with the circle, take away the trapezoid, I put in my formulas here, pi r squared, which is going to be pi times the radius. Notice the diameter is 20, so the radius is going to be 10 squared. And if you actually calculate that, 100 times 3.14 is 314 centimeters squared, minus 1/2 times the height, which is 8, times b1 plus b2, which is 32. So it's going to be 4 times 32, so 64, 128. So minus 128 centimeters squared, which is 186 centimeters squared. That's the area. Okay, for the now you try. Try it, hit play when you're ready to see the answer. So you should get 10.26 inches squared after you take the circle minus the rhombus. I'll do the work and place the answers here for you, but we can go over these in class if you need.